In today's video, we are going to explore the topic of ionic compounds by focusing on how they are structured, what properties they possess, and how we can determine their chemical formulas. When we talk about ionic bonding, we are generally referring to a situation where a metal atom such as sodium donates or transfers one or more of its electrons to a nonmetal atom such as chlorine. This transfer results in the formation of two oppositely charged ions, one being positively charged and the other being negatively charged. These ions are then attracted to each other due to the strong electrostatic forces that exist between them, forming what we call an ionic bond. The substance created from this process is known as an ionic compound. While this is usually demonstrated with just a pair of atoms, in reality, ionic compounds involve enormous numbers of ions arranged together. In these large structures, the positive and negative ions are arranged in an alternating pattern so that each ion is surrounded by ions of the opposite charge, and this attraction occurs in all directions. The result is the formation of a three-dimensional regular lattice structure, which is a highly ordered and repeating pattern of ions. In diagrams, the positively charged sodium ions may be shown in green, and the negatively charged chloride ions in red to visually represent their alternation. Another way to represent these compounds is by using ball and stick diagrams, where different colored spheres represent different ions and sticks are used to illustrate the ionic bonds between them. Now, let us look at the physical properties of ionic compounds. One key property is that ionic compounds have extremely high melting and boiling points. Another important property is that they can conduct electricity, but only under certain conditions, such as when they are in a molten state or dissolved in water. To understand why the melting and boiling points are so high, we need to think about what holds these substances together. In an ionic compound, there are countless strong ionic bonds, and it takes a significant amount of energy to break all of them. Therefore, they only melt or boil at very high temperatures. As for electrical conductivity, it depends on whether there are any charged particles free to move. In the solid form of an ionic compound, all ions are fixed in place within the lattice, meaning they cannot move, and thus the substance cannot conduct electricity. However, once the compound is either melted into a liquid or dissolved in water to form an aqueous solution, the ions are free to move around, and this allows the substance to conduct electricity. Finally, we need to understand how to determine the formula of an ionic compound. Let us return to the example of sodium chloride. Sodium forms a positive 1 charge when it becomes an ion, and chloride forms a negative 1 charge. Because the positive and negative charges cancel each other out in a 1-to-1 ratio, the formula of sodium chloride is simply written as sodium chloride. Now consider a different example, such as magnesium chloride. Magnesium is a group 2 element and forms an ion with a positive 2 charge. To balance this, we need 2 chloride ions, each with a negative 1 charge, in order to make the compound electrically neutral. Therefore, the formula for magnesium chloride is magnesium with 2 chloride ions. In this case, we write it as magnesium followed by 2 chlorides. Things become slightly more complex when we deal with polyatomic ions, which are ions made from multiple atoms rather than single elements. Examples include hydroxide and sulfate ions. These ions do not appear on the periodic table, so we must memorize their charges and structures. The hydroxide ion consists of 1 oxygen and 1 hydrogen and carries a negative 1 charge. The sulfate ion, made from 1 sulfur and 4 oxygen atoms, carries a negative 2 charge. Let us take the example of calcium hydroxide. Calcium, being in group 2, forms a positive 2 ion. Since each hydroxide ion is negative 1, we need 2 hydroxide ions to balance the charge from 1 calcium ion. Therefore, the formula is calcium with 2 hydroxide ions. When writing this, we must place the hydroxide ion in brackets followed by a small 2 outside the bracket to indicate that the entire hydroxide group appears twice. Now, let us look at aluminium sulfate. Aluminium, a group 3 element, forms a positive 3 ion, and sulfate is a negative 2 ion. Since we cannot simply match one of each and achieve neutrality, we must find the smallest common multiple of 3 and 2, which is 6. To achieve a total positive charge of 6, we need 2 aluminium ions. To get a total negative charge of 6, we need 3 sulfate ions. When we put this all together, the correct formula becomes 2 aluminium ions and 3 sulfate ions. In written form, this would be aluminium subscript 2, sulfate in brackets followed by subscript 3. It is also helpful to remember a few more polyatomic ions that commonly appear in compounds. These include the nitrate ion, which is made of 1 nitrogen and 3 oxygen atoms and carries a -1 charge, the carbonate ion, which includes 1 carbon and 3 oxygen atoms and carries a -2 charge, and the ammonium ion, which contains 1 nitrogen and 4 hydrogen atoms and carries a +1 charge. Learning these specific ions and their charges can be extremely helpful when balancing formulas and determining the correct chemical composition of ionic compounds. If you struggle to remember them, it might be useful to make a flashcard or take a screenshot to help you study them more easily.